So on to a few calculations between particles and moles. Okay, so how do we get from particles to moles and back again? This should seem pretty obvious if we remember that 1 mole is equal to 6 times 10 to the 23 particles. So if I have a number of particles, I divide that number of particles by 6 times 10 to the 23 and it will tell me the number of moles I've got. And then if I have a number of moles, I times that by 6 times 10 to the 23 and it will give me my number of particles. So it's pretty easy to change between the number of particles and the number of moles. So for example, if I have 1.8 times 10 to the 24 molecules of CO2, how many moles do I have? Well, I divide 1.8 times 10 to the 24 by 6 times 10 to the 23, and that gives me 3 moles of CO2 molecules. Now, sometimes we could be asked something a little bit more complicated. So in this case, a follow-on question could be, so how many atoms of oxygen are there in those 3 moles of CO2 molecules? Now, with this, we have to remember that we've changed from the number of molecules to the number of atoms. Okay, so we're looking at a different component. So just because we have 3 moles of CO2 molecules, it doesn't mean we have 3 moles of atoms of oxygen. In fact, because there's 2 oxygen atoms in a CO2 molecule, we have to times 2O2 by the 3 moles to work out that we actually have 6 moles of oxygen atoms. We've got twice as many moles because we've got twice as many particles because there are 2 oxygen atoms in each molecule. So we've got 6 moles of oxygen atoms. We do 6 times 6 times 10 to the 23 to find out that we have 3.6 times 10 to the 24 atoms of oxygen. So you do need to be careful, as I said in the last video, to specify which particle you're talking about, because this movement from number of atoms to number of molecules means there is a different number of moles in that.